business analytics, information systems/technologies, data science and analytics, statistics, and computer science. Those are the 5 most popular degrees for people who have jobs in analytics, either as a BI/BA professional, a data scientist, or a data analyst. Hi, my name is Shashank Kalanithi, and on this channel, I teach you how to break into the world of analytics. Stay tuned to see exactly how I figured that out. So anyone that follows my channel knows that we do a lot of coding on this channel. I love to take you guys into the actual journey of what a data analyst or a data scientist does and walk you line by line through the code. And coding is not the easiest thing to pick up. Honestly, it can be very difficult. And like I always say, it's not even the best solution in all situations in order to do what you want to do. Like sometimes I'll put stuff into a BI solution such as Tableau or Power BI because visualizing in those tools is easier than using code. All that is to say, I don't think coding is always the best solution, even though it's what a lot of my channel is about. And that's why I'm super excited for this week's sponsor, Composer, which is an automated trading platform that allows investors to seamlessly build a portfolio of rule-based strategies. Basically, it's a completely free platform where you can create an investment strategy and execute on it completely for free. Composer breaks the strategy creation process into different building blocks, which can be infinitely combined using a no-code visual editor. So you don't have to mess around with Excel spreadsheets. You don't have to mess around with code. You can go straight to actually executing any ideas that you might have in relation to investing strategies. And even if you're really into coding, the great thing about tools like this is that they really push forward programmatic or design forward thinking, basically thinking about how all the parts of your system will work together as you design them prior to actually creating it. And that's what tools like this are really great at helping you out with. They even have a couple of pre-vetted strategies, and you can even follow portfolios such as the Dragon portfolio, which actually is based off of Artemis Capital Management's Dragon Fund. And they kind of made a version of it that you can copy over here. So you can take, trading strategies of some of the best hedge funds out there and implement them yourself for fun or to see if you can beat the market. So again, Composer is completely free to use. Feel free to check it out using the link in the description below. And be sure to also check out the disclaimer in the description below, as it just has some information that you need to put out there whenever you are talking about a financial product. But I'm super excited to have such a cool tool on the channel, and I plan on using it in the near future to try out a couple of investment strategies that I have burning in the back of my head. All right, guys, so let's get right into it. So you guys saw the 5 degrees that are most popular. Again, business analytics, information systems/information technologies, data science/analytics, statistics, and computer science. I created this quick Tableau dashboard that you can see in the link in the description below. It's available on Tableau Public, which shows my findings. Basically, the process I used to go through this was I scraped 500 profiles from LinkedIn using the query data analyst. So I went to the search bar, I typed in data analyst, and scraped 500 profiles using my LinkedIn account. So that's the reason I can only get 500 accounts, because what happens is you're not supposed to scrape off of LinkedIn. They throttle you if you try doing it for too long. And that's why you can only get about 500 before they'll cut you off. And you don't want to mess with that because they will ban your account based on that. So you did not want to mess with that. And then I grouped the jobs into BI/BA, so business intelligence, business analyst, data analyst, and data scientists. And there was a group of others that came through as well. I just filtered those out of the dashboard. And I grouped similar degrees. So like accounting, accountant, stuff like that all went together. I grouped all business degrees together. So you'll have like MBA with a specialization in XYZ. So I just grouped all MBAs and all BBAs together. I separated the two because an MBA would go under master's and a BBA would go under bachelor's over here. So BBA, bachelor's in business administration, MBA, master's in business administration. And then grouped together things like engineering. I separated out computer science. So computer engineering, computer science, that all went in one area. And then information systems, information technologies, all those groups went together as well. You can go ahead and download this workbook and explore the data more deeply. But let me show you how exactly I parse the data after we go through this real fast. So looking at the data over here, you can see this says the degrees for data analysts and data scientists. Now, I personally have a chemistry degree. So I think if the question is, can I become a data analyst with any degree? I believe you totally can. That being said, if you're trying to decide what degree to get, it probably would help to have some concrete answers as to what are some of the more popular degrees. So as you can see from here, at least in the network that I have, masters were a lot more common than bachelors. And we'll go over the biases of this methodology in a bit. But masters are more common than bachelors. PhDs were not very common. And I actually dropped associates because there was almost no one that had only the associates from the profiles I was able to scrape. And you can see amongst bachelors, it looks like statistics/mathematics was the most common, followed by economics and econometrics, followed by computer science. And that makes sense because business analytics, as far as I'm aware, is not a really popular degree as a bachelor student. That might be changing. I know data science is becoming a degree that you can take as a undergrad now, that it wasn't back when I was doing undergrad, at least at the college I went to. And if you're in the master's programs, it looks like business analytics and information systems / information technology, so IS and IT, MIS would be grouped into this as well, are both the most popular degrees, followed by data science / analytics. Statistics is significantly lower on the spectrum, actually. Oh, it's all the way down here after comp sci as a degree. So that kind of gives you an idea of what the kind of landscape looks like. And you can see the degree totals down here. Again, you can go ahead and play around with this workbook in the link in the description below. Total profile scrape. So I scraped about 459 profiles, but only 370 people of those 459 profiles had data jobs. Again, I wouldn't call this a representative sample, but it's definitely better than nothing. And I think this is the most rigorous analysis I've done of what degrees are most popular amongst people working in the analytics industry. Otherwise, I would kind of always just wing it and give the answer that made the most anecdotal sense to me. So let's go to the code and actually decide how, go through the biases that I had and kind of look into what I did in order to get a hold of this data. So I put together this workbook. I will probably put out this workbook after removing all of the outputs. That way you guys can go check it out. You can probably get in the GitHub link in the description below. But basically what we did was the whole purpose of this video was I wanted to know what degree you need to break into the world of analytics. I personally have a chemistry degree, but I assume that people usually get different degrees to break into this field. Like there aren't many, I haven't met many people with natural sciences degrees in the field. I'm definitely one of the more unusual ones in that case. I know a lot of people like to scrape job openings because job openings will say looking for people with these degrees, but I don't find that to be too useful. I don't believe that's the best method to go about it because I think that what job postings say they want and who they actually hire are not always the same thing. Especially after you have like a job or two, no one really cares about your degree, save some specific jobs where like very specific knowledge might be necessary. So I wanted to see what degrees people in the industry have, and that's why I decided to scrape profiles instead of scraping job listings, which is what most people do. Initially, I searched data analyst using my profile because LinkedIn has CAPTCHAs that show up if you don't log in. So I had to log in, I had to use my profile, and I searched the word data analyst. And it's really important to understand the kinds of biases that will show up because I used my profile to search for this. So locations are going to bias places that I've lived in. So you'll see a lot more people from the Seattle, Dallas, and Atlanta area. So I went to college in Atlanta. I'm originally from Dallas, and I currently live in Seattle. There will be a disproportionate number of people from Nordstrom, the company I currently work at, and the largest company I've ever worked at. And people with, there will be a disproportionate of people from Nordstrom and people with educations from Emory. There we go. Need to correct that. And there will be a disproportionate number of people with higher level degrees. So just the, to put it bluntly, the kind of like social group that I hang around, master's degrees are not at all uncommon. It's really common for people that I know to have master's degrees. So I think that master's degrees as shown by this Tableau workbook over here might be a bit overrepresented. That being said, of our favorite YouTubers between Tina, Ken, and Luke, all of them have master's degrees. So maybe it is actually the more common degree to have. So what I did is I went and I searched data analyst, and then I individually downloaded the 100 pages of search results. And the reason I did that is because I wanted to make sure that I saved my quota of the number of pages I could scrape. Because what happens is you can scrape about I've done scraping on LinkedIn before. You can scrape about 500 things before the system shuts you down. I probably will not be doing another project like this because LinkedIn is quite serious about stopping this and they really want to protect their data. They actually used to have an API, but they figured that they have some of the best data in the industry and they want to protect that. So they could, cancel my profile if I did that, which would be problematic because I have 5,000 followers on it. So if you haven't followed my LinkedIn profile, be sure to follow it soon. So I downloaded the first 100 pages of search results. So that would give me 1,000 profiles because there are 10 listings per search page. And I went ahead and imported pandas. And let me zoom in for you guys. That way you guys can see this more easily. So I went ahead and imported pandas, which is the Python data frame library. It's for any tabular data that you need to manipulate. It's the easy way to manipulate that data. Then I went ahead and imported Beautiful Soup. Beautiful Soup is a library to parse out HTML files. So the HTML is what determines where the content on your page is displayed. So there are kind of three major languages that are used whenever displaying you're displaying a web page. HTML, CSS, and JavaScript. HTML is kind of the skeleton of the web page. It kind of tells you where everything is for the most part. CSS will tell you how everything looks, and JavaScript will help you with any interactive elements on your page. So I'm simplifying over here, but that's more or less how it works. And so we want the HTML data because that is where all the information is. So I went ahead and imported Beautiful Soup, which is a standard Python library to parse out HTML files, and then OS, which just lets me do some commands that like within my folder structure. I used list comprehension to create a list of files. So you can see over here of all the different search pages that I downloaded. As you can see, I kind of gave them just random names as I was downloading them. And then what I did is I looped through each of the files, so each of the search page results, and I wanted to parse out the profile link, the job title, and the company name. So whatever the name of someone or whatever the link to someone's profile was, what is their job title and what company do they work for? So what I did is I created this for loop over here, and we'll stay zoomed in. I created this for loop over here, and then you'll see for file in files, so for each file in the files list, we went ahead and opened up the HTML file, and then for entity in soup.findAll. So what soup.findAll does is it goes and it looks for, it'll find all of a class tag inside the web page. So let's see if I can demonstrate that for you guys. So let me go ahead and bring up google.com, and we'll put this over here, and I'll make a web scraping tutorial in the future. So if I hit F12 on my computer, you'll see we get this page over here. This is your page source, and you will see there's this class tag over here. It says FGVGJC, and that correlates to something way down there. So what I can do is I can click on this little button over here, and I can see what does the search bar correlate to. And you'll see the search bar correlates to SDKEP. So basically what I was doing was I was looking for the class tag that contained the entire search result. And then within that, I went ahead and got the link to the person's profile page. And that's this entity result title line, 2 lines. That's how you get that. Then I went ahead and just printed that, and then I appended it to this links list over here. And then I just did the exact same thing for job titles and companies. Yes. Yeah, okay, so I got the text, and then so I pulled all the text information out from it, and then I went and I split that up to get the jobs text and then the company's text. So for anyone not familiar with web scraping, I'll go ahead and create a tutorial to show you guys exactly how it works. I don't want to run it right now because it'll like show people's names and stuff like that, and I want to protect their privacy. But hopefully I'll have a couple of animations that you guys can see. So we get all those links, and then one thing that's really important is to make sure that I have the same number of links for everything. So as you can see, I scraped a 1,000 results, and then there was about, I'm guessing about 19 of them were kind of junk results. So they were kind of like faulty results that don't actually lead anywhere. And so that gave me 981 results. And so I created a data frame called the data, which has the link to someone's page, what their job title is, and what company they work for. So then we go ahead and we import Selenium, and Selenium is a Python library that allows you to test, it allows you to act like you're clicking and typing in stuff into a web browser. So I imported Selenium, and I am going to be using Chrome. You can use it with Firefox too as well if you want though. I create a driver object using the chromedriver.exe file on my desktop. And then what happens is we iterate through that list of profile links, right? These links over here. We iterate through that list, and then I pull the entire web page and I save it in my computer. I don't want to parse it right now because what happens is the actual pulling of the web page is the slow part. Parsing it is usually really fast, so I always recommend pulling the web page, saving it somewhere on your computer, and parsing it later. Also because just because of bad connections and stuff like that, your pulling job can fail at any point in time, and so you want to finish it as fast as possible. So we are going ahead and pulling all of our data. You'll see I did a couple of interesting things here to try and trick LinkedIn a little bit. So we have our wait time random.rand range over here. So basically what happens is I am creating a random integer between 20 and 30. And then I'm telling Python to sleep for anywhere from 20 to 30 seconds randomly after each iteration. And I was kind of hoping that that would throw LinkedIn off my trail and be like, okay, like he's just going through pages at a relatively slow pace. Like 20 to 30 seconds per page is totally something a human could do. But what happens is I got cut off because I think there's a maximum limit of profiles you can look at within a 24-hour period. So I'm guessing that's about 500. I wouldn't recommend you do this with your own account, but if you want to, then I think if you keep it under 500, you might be able to, get data as you want to, but I would not recommend it. So as you can see, eventually it failed at around 464. So then what happens is we have all of our HTML profile pages, right, in our computer. I go ahead and I import the same 3 libraries you saw earlier, Pandas, Beautiful Soup, and OS. And then I create that same list of HTML files, except now it correlates to the pages, the profile pages of people that we are scraping data off of. And I want to get their job, their location, their company, and their degree. I was thinking about getting the university that they went to as well, but I didn't feel like it would be particularly useful information. I think that, broadly speaking, there are universities that are better for certain degrees and stuff like that, but they kind of fall into like large buckets. So I was kind of just like, let's just forget about that, not get the university. So we went through and I printed the file, that way I knew where I would be at, because the TQDM package, which is the package most people use to count the number of iterations that their for loop is going through, operates really weirdly in Python notebooks, so I just don't use them in Jupyter notebooks. Went ahead and opened up the HTML file as per usual. And then we went ahead and found all of this class over here. And this class, I think, is this is where, if you've seen LinkedIn, you'll notice that there is a, actually I can probably just show you guys on my page. If you look over here, you'll notice this card over here that says experience. And there's another one that says about. They all kind of look the same. And then there's one that says education over here. Each of these cards represents a Art Deco card, Ember View, Breakwords, PV3, MT4. That's what that class is called. And so we're pulling each of those cards. And then I am searching each of the titles to see if experience shows up or education shows up. For some reason, when I pull the text, it says experience, and education, instead of just saying experience or education as single words. I'm not exactly sure why. So I go ahead and I pull that card, and then I just divide. So you'll see down here, I create a little portion of my script to just cut that string in half. That way it'll say just education or just, experience. And we go ahead and pull all of their information using just a couple of more class tags. So relatively simple stuff. And I do a couple of try except statements because people's profiles are designed differently. Some people don't have an education section. Some people don't have an experience section because they're like, say, interns or something like that. Or they're like college students. And I need some fail safe to make sure that the script doesn't fail just because that happens. And we actually append a blank data for if they have no degree, or at least no degree that I can discern. So then we get a clean data set that looks kind of like this, where you have your job over here, your location over here, company, and then degree. And one thing you'll notice with the company is that some of these have this little dot over here that separates the company from the type of job that it was. I think the type of job is also important as well. I think that there are basically 5 types of jobs out there. There's contract positions, full-time positions, part-time positions, freelancing positions, and internships. I think those are like the 5 different job types you can have on LinkedIn. That sounds like it. And I wanted to know what job types people had. So I just did a string split on that little dot over there. And then if the job type was available, it would split it. So you'll see that's basically what we're doing over here. So then we get the contract, that Google contract are now separated from one another. And that is all the data cleaning that happened over here. Then I went ahead and I created my CSV. And then we go to the Tableau workbook where I do the rest of my data cleaning. So let's go over here. So I went ahead and I imported the data set, and you'll see there are all these groups over here. So basically what I would do is I would go in and start grouping together like cities, because people will call Seattle a bunch of different things. So like they'll say like Bellevue, Greater Seattle area, Redmond, Washington. If they said Washington, I just put Seattle. That way I could like group the data and plot it out on a map if I wanted to. I didn't find the map findings too interesting, but feel free to download this workbook and create something if you want to on your own time. For example, Houston, Texas area and Houston, Texas got grouped together. I'm trying to remember which one. I think New York is a really, or no, San Francisco is a really good one because people are all over the place over there. You'll see over Sacramento, San Diego. Where did I put San Francisco? Oh, I guess it's not necessarily alphabetical order. Yeah, under San Francisco, like Campbell, California, Cupertino, Fremont, Mountain View, Newark, Palo Alto, San Francisco, San Jose, Sunnyvale. I just grouped all of that under San Francisco. And the reason I do that instead of saying the Bay Area or something is because Tableau has very finicky geolocation like kind of parsing. And so I always just like to pick the biggest city that things are close to and just group it over there. You'll see there's even some stuff in Maryland that I just called Washington, D.C. because it was closer to Washington, D.C. than it was to Baltimore, for example. So you'll see I didn't think too hard about where I was putting stuff. It wasn't that important, quite honestly, because I knew the data was going to be very heavily biased towards towards Seattle and Atlanta and New York. Seattle because that's where I currently live, and then New York because a lot of Emory people go to New York as graduates. It's just one of the most popular cities for them to send their graduates, and I think most people moved out of Atlanta by now. I'm a couple of years removed from college, so I think most of my friends are out of Atlanta now, and they've gone to their second or third jobs at this point. So we went ahead and did a lot of grouping, and then what I did is I also went ahead and I split out I did the same thing for degrees. So all these BAs, BSs, Bachelors of Science, bachelor's degrees, I split them all, I put them all together under bachelors, did the same thing with masters. So MBAs, Master of Economics, those are all just masters. And then I went ahead and I did I grouped, not degree type, grouped degrees. There we go. I went ahead and I just kind of grouped degrees into groups that kind of made sense for me. So you'll see under finance, there's like banking, finance and information systems. Again, you can break this out if you want to. I grouped them together that way because I didn't have that much data. That way the story would be a bit more interesting and there would be something more to tell. And so you'll see under information systems and technologies, there's like all these degrees over here that I grouped as information systems and technologies. Comp sci, just a bunch of comp sci stuff. This person has comp sci and French. If they had 2 degrees, I just took the first one because I assumed there's a reason that they listed that one out first. Quantitative sciences are over here. And then you have like analytics. And then I had a separate one for data science and analytics, which I guess I could have grouped these 2 together to be 100% honest. So I might even do that. So let's actually just go ahead and do that. There we go. Now data science and analytics are the same group. And yeah, that is basically it. So based on the data that we have, it looks like the most common degree for people to get are business analytics degrees, followed by information systems and technology, data science and analytics, stats and mathematics, and then computer science. So what would my opinion be of all of this? I think that at the end of the day, if you really want to break into this field, then I think business analytics is a tremendous degree to go ahead and get in the first place. Comp sci, you can never go wrong with that either. Some of your favorite YouTubers have comp sci degrees and are in this space. I have a chemistry degree. So if you've already graduated college and you want to be a data analyst, for example, I wouldn't necessarily recommend going back to college and getting a new degree. I'm not saying don't do that. Maybe that is the right move for you, but consider very seriously. I would say you really do not need a relevant degree to get into this field. But if you have the opportunity to go, and as in you're going to college or you have an opportunity to change your degree right now, business analytics seems to be the one that's most common. After that is information systems and technology, and then data science and analytics degrees, which are becoming more popular as time goes on. But I hope you guys found this video interesting. It's a bit of a short one because it took me a couple of days to get all that code set up because web scraping can be really, really finicky. But I hope you guys found that interesting. I hope that you found it informative. If you have any questions, feel free to leave them in the comment section below. I'm usually down there answering questions for a couple of days after the video uploads. I'm hoping that this video does really well, especially with the whole front loading the answer to the question at the beginning of the video. But I hope you guys have a great day, and thank you guys so much for watching.